So today we are going to learn how to solve literal equations. We're going to divide this into two parts. Most of what we do today will be like one step literal equations. Okay. Now our goal is to rearrange formulas, and we're going to talk about how formulas and literal equations are the same thing. And we're going to highlight a variable of interest. And all that's a wordy way to say what I'm about to show you. Okay, so what is a literal equation? Well, a literal equation is an equation that is mostly variables. Mostly variables. So, for example, formulas are literal equations. All right. So, if I have, you learned last year the area of a circle. So, the area of a circle is pi times the radius squared. Since that is mostly variables, pi is a number, but we write it with a symbol, right? That is a literal formula. I'm sorry, a literal equation. And the deal with literal equations is, well, what if I wanted to solve for r? What if I wanted to write r using a and pi? That's what we're going to learn how to do with literal equations. Another one, let's say the area of a triangle. The area of the triangle is 1/2 base times height, right? Well, this is mostly variables. We've got the A for the area, B for the base, H for the height. Let's say I wanted to know, well, how do I find the height if I know the area and the base? Well, we're going to use literal equations and isolating a different variable in order to be able to do that. So the next question that I just know is on all your minds is, how do you solve a literal equation? Well, you solve a literal equation just like you solve a normal equation. We're going to use inverse operations to isolate the desired variable. So if you look for the variable you want to isolate and then use your inverse operations just like you would in a normal equation, you will be able to solve a literal equation. Like I said, most of what we do today is going to be dealing with one step literal equations. So let's look at examples using addition or subtraction. So let's go back to 6th grade. We've got 3 equals x minus 2, and let's say we wanted to solve this. Okay, well, we look at this minus 2, we're trying to isolate x. So the inverse operation to subtraction is addition. We would add 2 to both sides, and we would get x is 5. Okay, we're going to use the same idea on these literal equations. So this is m equals c minus s. Now, some of these are actual formulas that mean something, and some of them are something a math teacher somewhere made up for us to have some practice to do. Okay, so here we have m equals c minus s, and they tell us to solve for c. So we're going to find c. That's what we're trying to isolate, and we've got this minus s in the way, right? It is what is keeping c from being isolated. So my inverse operation to minus s, I'm going to add s to both sides. Minus s plus s, those are inverse operations. That becomes 0, so that goes away. I'm left with c equals, now this is what looks kind of weird. Up here, we could add the 3 and 2 and get 5, right? But m and s are not like terms. We can't combine them. So what we do is we just copy. So c equals m plus s. So if you can't combine it, you just copy it down. All right? Next one, we're solving for u, and we have t equals u plus v. So I find u, that's the one I want to isolate. I have a plus v, so my inverse operation would be minus v. Plus v minus v becomes 0. That goes away. I'm left with u equals t minus v. Those are not like terms. I cannot combine them. So I just copy t minus v. Now let's look at one-step literal equations that involve multiplication or division. So let's go back to 6th grade again. We have 3y equals 12. I need to isolate y. This is 3 times y, so my inverse operation is division. So I'm going to divide both sides by 3. This 3 over 3 becomes 1. It cancels. And y equals 12 divided by 3 is 4. Okay? Going to be very similar when we're looking at literal equation. So here, this is an actual formula. You'll use this year in science. So D equals R times T. This is distance equals rate times time. Okay. And I need to solve for T. So I look at T, it's right here. R is what is keeping it from being isolated, and this is R times T. So my inverse operation is to divide by R. R divided by R is 1, and I'm left with T. And T equals, well, D divided by R, I can't do anything with that, so I'm just going to write D divided by R. Okay, so that's my answer. So here I had distance equals rate times time, but if I wanted to know the time, I would take the distance and divide by the rate. So that is how distance and time are related in this formula. Let's look at another formula that you're familiar with that you dealt with last year, the volume of a box, the volume of a rectangular prism. Volume equals length times width times height. And we want to solve for h. Now, here's something we can do that's kind of cool with a literal equation. We can do more than one thing at a time. I'm trying to solve for h, and L and W, length and width, are both multiplied by h. Since they're both multiplied, I can divide by both of them at the same time. That's an L and a W. Okay, so I'm going to divide that side by LW, and I'm going to divide the other side by L times W. So that cancels and that cancels, and I'm left with H. And over here, all I can do is copy V over length times width. Okay, so if volume equals length times width times height, then the height is the volume divided by the length times width. All right, so let's look at these division problems that sometimes throw people off. This is M divided by 3 equals 7. So I'm trying to isolate M. This is division, so my inverse operation is multiplication. So I'm going to multiply both sides by 3. These 3 cancel, and I'm left with M equals 21. All right. Now, here's another formula that you're going to deal with in science this year about density. Density equals mass divided by volume. D equals M divided by V. And I need to solve for M. Well, right now, M is right here, and it's M divided by V. So my inverse operation is multiplication. These V's are going to cancel, and I'm left with M equals, and you could write this several ways. I'm going to put the capital D first, so D times V. So where density is mass divided by volume, mass is density times volume. Okay, let's look at 2 more types of problems briefly. Let's look if a fraction is involved. So let's go back to a normal equation. Now we're in 7th grade. This wasn't 6th grade. But 1/4 times z equals 7. Now we've talked about how you divide both sides by a fourth, right? And if you divide by a fourth, you flip and multiply, right? So we're really multiplying both sides by 4/1, or just 4. So these cancel, and I'm left with z, and 7 times 4 is 28. Okay, so let's take that area formula that we talked about earlier. Area equals 1/2 base times height. This is the area of a triangle, and let's solve for the height. Well, the first thing I've got to do is get rid of this 1/2. And I could divide both sides by 1/2, but dividing by 1/2 is the same thing as multiplying by 2. So I'm going to multiply both sides by 2, and I get 2a equals this 1/2 and this 2 cancel, and I'm left with BH. Now, I'm trying to isolate H. B is still in the way. This is B times H, so my inverse operation is division. Those B's will cancel, and H is 2 times capital A, and the capital matters. Make sure you pay attention to what kind of letter is being used. All divided by B. So if the area of a triangle is 1/2 times its base times its height, the height of a triangle is 2 times the area divided by the base. So these 2 formulas are the same thing, they're just rearranged. All right, lastly, what if I've got parentheses involved? So here I have h times, in parentheses, f plus g equals K. And I'm trying to solve for H. Always find that variable you're trying to isolate. So this is H times F plus G. So what's my inverse operation? I'm going to divide both sides by F plus G. Now, you can leave that in parentheses if you want. It's not really wrong on this if you don't, but if it would help you to not forget that that is grouped, you can do that. So I end up, this F plus G and this F plus G cancel, and I have H equals K over F plus G. And in that case, you can write the parentheses or not because the fraction bar, remember, is a grouping symbol. Okay, what about this one? B over 2A equals C plus D. So I'm solving for capital B. So this is capital B divided by 2A. So what's my inverse operation? I'm going to multiply by 2A. So I'm going to multiply that side by 2A and the right side by 2A. Now here's where you have to be careful, okay? Those cancel, and I get B equals, and since this C plus D was already here, we have to write it in parentheses. So you have to add the parentheses there. So that is, and somehow I just made the weirdest looking 2 in the world. C plus D times 2A. Or you could also write 2A times C plus D, right? Because of the commutative property of multiplication. All right, now that's a bunch of examples. It's kind of weird. Do some practice. And if you have any questions, please ask.